What are intermolecular forces?
Intermolecular forces are the forces of attraction between molecules. They are also known as van der Waals forces. Intermolecular forces are very weak attractions, unlike covalent bonds and ionic bonds, which are stronger in attraction.
Don't confuse intermolecular forces with intramolecular forces, which are the forces that bind atoms together. These are chemical bonds, while intermolecular forces are physical bonds.
This type of intermolecular force is London dispersion forces. In molecules, the electron density is not evenly distributed throughout the molecule. This creates a temporary dipole which interacts with other dipoles. London dispersion forces are in all molecules. So, for example, in the picture below, the electrons in a molecule or in an atom can tend to move to one side more than the other. So the one that has more electrons becomes the negative side, and the one that has less is the positive side. And the positive side of one atom and the negative side of the other atom interact with each other. London dispersion forces are the weakest type of intermolecular force. London dispersion forces continued. London dispersion forces are the only intermolecular force in nonpolar molecules and atoms. So they're in every single molecule, but in nonpolar molecules, this is the only force that exists in it. And they increase as mass and electron number increases. So in the picture below, you can see the bigger molecule with the bigger surface area is going to have the higher London dispersion forces.
The next type of intermolecular force are dipole-dipole forces. Dipole-dipole forces are the electrostatic interactions between the molecules which have permanent dipoles. So that means they are only present in polar molecules. Dipole-dipole forces generally are stronger than London dispersion forces, but like in these London dispersion forces, if the atoms are much stronger or much larger, then they could be stronger than the dipole-dipole forces.
The type of intermolecular force is hydrogen bonding. It is the strongest intermolecular force, and is the force of attraction between a hydrogen that is bonded to a highly electronegative element, such as F, O, or N. So over here we see that hydrogen is bonded to an O, and this actually isn't the hydrogen bond, but because this H is bonded to a really high electronegative element, then it allows these two molecules to form a hydrogen bond right here.
Okay, now on to boiling point. There are a few ways that intermolecular forces impacts the boiling point. So, if a molecule has hydrogen bonding, it will have a higher boiling point because hydrogen bonds are stronger than the other ones. So, over here, you see that we have CHCl3, also known as chloroform. So, its boiling point is 62 degrees Celsius versus H2O, which has two hydrogen bonds, and its boiling point is 100 degrees Celsius because it has two hydrogen bonds, while CHCl has none.